on the basis of results of the model test. And then from that we can calculate that my ship which I am planning to build, how much of power will be required in kilowatt, unit of measurement is kilowatt, and then accordingly we can select whatever the make of engine I want, but important is that what power or shaft power is required for that vessel. So we have to know what is resistance. Now when a vessel is moved or rather stored, let us say, and it is moving at a speed v, then it experiences a resistance because of the movement of the vessel, and that resistance is dependent upon various factors. One of them is the speed, correct? One of the resistance is because the more is the speed, more is the resistance, and therefore the propeller must provide me a thrust which will overcome the resistance to move it at speed v. For example, if I am moving the vessel at speed v and the resistance offered by water to the hull, I am taking just an example, let us say if the resistance is 1000 newtons. Therefore, by propeller, if it produces this much of power or thrust, vessel will move at a speed v. Because my propeller is giving me same thrust. Thrust is a force, resistance is also a force. So if the resistance is 1000 newtons, therefore the propeller must, if it is giving me 1000 newton thrust, the vessel will move at a speed of v. Correct? Is it clear, this point? If I give instead of 1000 newton, 1200 newtons of force, unit of force SI unit. We are following all SI units. SI. So let me make it clear, SI units. The unit of force is newtons. The unit of pressure is Newton per meter square. Unit of work done is Newton meter, and unit of power, because power is nothing but rate of doing work. So Newton meter per second. Newton meter per second is power. 1 Newton meter per second is equal to 1 watt. 1 Newton meter per second is equal to 1 watt of power. But Newton is a small unit of force, and in shipping, or when we are talking about ship, we normally use the unit as kilo, because Newton is a very small unit per second. This is work done. Rate of doing work is power. Pardon? Work done is Newton meter and dash m. So if I say if a 1 Newton force is moving the object to 1 meter, then the work done is equal to 1 Newton meter. Correct? That is the work done, because the object has been moved. Power के लिए क्या है?
Newton per second.
And इसमें n Newton meter per second. That means in 1 second how much work is being done? That is called power. 1 Newton meter per second is equal to 1 watt. And if I, instead of using small unit, if I use 1 kilonewton meter per second, the answer will be in kilowatt. This is what we normally use. because power is pretty big. When we do the calculation for power, I will explain it further, how the work done and power is calculated. But at this moment, these are the basic definition for SI units which we'll be using. And pressure, which is in SI unit Newton per meter square. The normal unit or the instrument what we use, they normally give us in bar. Pressure in bar per kilogram per centimeter square. But we are using SI unit, and 1 bar is equal to 10⁵ Newton per meter square. This also we will use somewhere else, but just to give you an idea about the units, what we use for measurement. Now the speed, let me make it capital. So in all of our calculations, if I write V, then it means the unit of measurement is in knots. V, wherever in formula I use a V, it is knots, speed in knots. Like we normally say, vessel is moving at 10 knots, 12 knots, 14 knots. So that is knots.
B is equal to 10.
Pardon?
B is equal to 10 knots.
B is equal to 10 knots. Anyway, if any ambiguity anywhere, I will keep clarifying. This is just for starting, so that we know what we are talking about. इसमें तो कोई डाउट नहीं है ना, यूनिट्स में you must be using in other numericals also, SI units, correct? मीटर में लेते हो, ग्राफ वगैरह सब, है ना? तो वही है. All right. Now coming back to our topic. So as I said, when the vessel is moving in water, then there is a resistance, and that resistance is because of water and hull coming in contact with each other. It resists this movement, and therefore the value of resistance also changes. But if I know, for example, that if the vessel is moving at V and corresponding to the speed V, the resistance is equal to 1000 Newton, then instead of towing, now this is tow resistance because I am towing the vessel, and I found that 1000 Newton force is required to move the vessel at V knots. But instead of towing, if I am using the propeller, then it must give me 1000 Newton of force or thrust to move the vessel at V speed. Is this point clear?
Yes, sir.
Okay. Now we come to this resistance. This resistance has got two components, and that is why we say RT is the letter we use for, and R is the resistance, T represents the total resistance, because resistance has got two components. One is called frictional resistance, RF, which is because of the friction between the water molecule and the steel, and we are assuming ship is made of steel. Plus, second type of resistance is called RR. This resistance is called residuary resistance. So that means this one is frictional resistance, and this one is residuary. Residual resistance is also called wave making resistance. Wave making resistance. Wave. When the vessel moves, some waves are created, and the energy comes, and please remember, I am not talking about any external forces, wind की वजह से भी है, sea is rough, I am considering only calm weather, and only the waves which are generated is because of the movement of the vessel. So in order to create these waves, the energy has to come from the ship's propulsion only, and therefore it is also part of resistance. Sum of these two is called the total resistance of the vessel. Pardon? Residuary resistance, RESIDUARY, residuary resistance. RR, the symbol for writing these two. Now, frictional resistance RF depends on certain factors. So that is why I can say RF is proportional to, when something depends on some particular factor, we can say if that factor is more, frictional resistance will be more. So therefore we use that symbol proportional to, or rather it depends on these factors. So frictional resistance depends upon density of water. More dense is the water, more is the resistance. That means if the vessel is moving in fresh water, the resistance will be less. If it is moving in sea water, resistance will be more. And how much more will depend upon what is the density. We are taking 1.025 as the standard. Of course, it may vary from one place to another. So that means if I know the resistance in fresh water, if I multiply by 1.025, it will give me the resistance in salt water. It also depends upon the roughness of the hull. More rough is the surface, you have
higher will the resistance.
More will be the frictional resistance. It also depends upon S. S is the wetted surface area. More is the surface, wetted surface area. If it is more will be the resistance. Pardon?
Wet surface.
Okay, S is the wetted surface. Wetted surface area is underwater area of the hull, right? If the hull area is more, which is underwater, more will be the resistance. That is why I am using the directly. Also, it depends upon the length of the vessel. And it also depends upon the speed of the vessel. So these are the factors on which the resistance, frictional resistance RF depends on. These are the components. Totally, all these factors will combine together based on what is the condition of the hull. Density water kitni hai, hull is clean or unclean. More is fouling of the hull, more will be the resistance, more power will be required to propel the vessel, correct? So these are the factors on which frictional resistance depends. Clear?
Yes, sir.
Okay. Now we come to the second part, residuary resistance. You must have seen on some ships you have bulbous bow. Purpose of bulbous bow is to reduce the residuary resistance, correct? And that is why in some vessels, especially the vessels which are larger length and moving at greater speed, waves created because are more. In order to reduce the residuary resistance, we make bulbous bow in some cases. Now let us see here residuary resistance. Residuary resistance has got three components. That means there are three factors which are responsible for contribution to this residuary resistance. Let us see residual resistance. First is the resistance due to formation of streamlines around the vessel. Due to lines around the vessel. Due to formation of streamlines. Now let us see if the vessel is a barge. Okay. As the vessel moves, what will happen? These are the streamlines which will be formed around the vessel. Energy comes from the vessel only, because as I told you, we are not considering any external factors. So barge will, a flat front, will have too much of resistance because of formation of these streamlines. However, if it is profiled nicely, then this resistance will be less. Understood? If say barge is moving with front, more resistance will be there. If you are profiling the forward part of the vessel, and that is why we always have very carefully profiled vessel, so that resistance due to formation of streamline is less. That is one part of the residual resistance. Second part, resistance due to formation of eddy currents. Eddy currents. Now eddy currents are formed wherever there is a change of cross section, right? So the vessel, the sketch or small diagram which I am showing you, does not mean the vessel is exactly like this. It is just to highlight what are the eddy currents. So if the vessel has not changed the cross section here, I am looking for the plan. These are the change of cross section. This is just one cross section which is shown just for explanation purpose. Along the entire hull of the vessel, wherever there is a change of cross section, these are the eddy currents, because they are localized, right? So these are called eddy currents. EDDY currents. Therefore, the designer also has to make sure that along the length, the change of cross section is not abrupt, but a smooth profile has to be given as far as possible. But 100% may not be possible. Third is resistance due to formation of waves. Formation of waves. Can I rub it off this side? Yes. So if the vessel is moving, then the waves are created because of the movement of the vessel. Again, I am repeating, we are not talking about waves due to swell, etc., or wind or nothing. This is for the because the movement. It is not, vessel is not traveling on a track, na? Railway track, it is in the water. So you have movement as well as forward movement. So therefore, these waves are generated, and the energy required is also from the ship. So these are the three types of resistances, residual resistance. Some of this is called residuary resistance, and that is why total resistance of a vessel is sum of frictional resistance plus residuary resistance.
एडीज नहीं समझ आ रहा
हाँ जी,
एडीज नहीं समझ आ रहा
एडी इज सिंपल.
इस तरह का कंस्ट्रक्शन तो बनेगा नहीं कभी. तो हमने बोला एब्रप्ट इस तरह का शिप साइड नहीं होगा कभी भी. तो अगर नहीं होगा तो देन हाउ द